So what if I gave you 8 minus 6i over 1 plus I? How can you actually simplify this? So you might think, okay, given what we've kind of learned about simplifying fractions, maybe I can just do the sort of, first term over the entire denominator minus the second term over the entire denominator. Well, if you go ahead and do that, it still doesn't really give you anything useful. You can't do anything with that. Something else that might be tempting, but you can't do, and don't try to do this. Something, again, that might be tempting is, oh, well, I can just divide 8 by 1 and then negative 6i by I. You can't do that. Again, when we're simplifying fractions, if you simplify, you have to do each term by the entire denominator. So then what are we left with? Well, so there's a tool called, not a tool rather, but there's something called the conjugate. The conjugate is when you have this exact same expression, or I'm sorry, this exact same binomial, but just with the opposite sign. And what is the point of using this? Well, watch. When you see, basically, almost any time you see a fraction with I in the top and bottom, you need to simplify it. This is your go-to. This is what you do. Just multiply the top and bottom by the conjugate of the bottom. So that won't change the value of this expression, right? Because I'm still technically multiplying this whole thing by 1, right? It's something over itself. So I'm not changing the value, but check out what you get when you actually do this operation. So let's just leave the top. Let me scoot over here. Let's just leave the top as is. I don't want to try to work through that yet, so I'll leave that as 8 minus 6i times 1 minus I. But what's on the bottom? Let's multiply this out. So you get 1 times 1, so we have 1. 1 times negative I, so minus I times 1, so then plus I, and then I times negative I, so you get negative I squared. So from here, you see that these two i's are going to cancel out, right? And you know that I squared has an actual numerical value. Like I squared isn't imaginary. I squared is just equal to negative 1. So why don't you rewrite it that way? So now we have, on top, we still have 8 minus 6i times 1 minus I. And on the bottom, we have 1 minus negative 1, right? So 1 plus 1, 2. So you've pretty much solved your major issue. You don't have i's on the top and bottom anymore. So if we continue trying to simplify this, let's just go ahead and multiply out the top. So we'll have, so 8 times 1, 8 times negative I, so negative 8i, negative 6 times 1, so just negative minus 6i, and then negative 6i times that, so plus 6i squared, all over 2. How do we simplify this further? We can combine these terms. Again, I isn't a variable, but you can still combine these like terms, and we know what I squared is equal to. So we do 8 minus 14i, right? 8 minus 14i, and then what's I squared? Negative 1. What's 6 times negative 1? Negative 6, so minus 6 all over 2. Let's move a little bit lower. Again, we can combine like terms, so it would be 8 minus 6 minus 14i. So we have, this is equal to 2 minus 14i all over 2. And now it's easy to simplify this, right? Now you can do the first term by the entire bottom and then the second term by the entire bottom. So this is actually equal to 2 over 2, so 1 minus 14i over 2, minus 7i. And you'll notice this is that a plus bi format where a is 1 and b is negative 7. And so pretty much always this is the most simple form of a complex number. This is called a complex number because, again, you have your real numbers and your imaginary numbers. And your goal usually when you're simplifying is to get it down to this form. So let's recap. How did we actually do it? We had a fraction. We can't do our normal sort of fraction simplification. So what we do is we multiply top and bottom by the conjugate of the bottom. It works because you're not changing the value because you're effectively multiplying by 1, but it cancels out your i's on the bottom every time. So let's go over one more example, do that together, and then we'll jump into some practice with it.